So today I'm going to teach y'all how to use a distributive property to your benefit on problems that may not make sense when you first see them, okay? So when you see a problem like this, the first thing that should pop up in your mind is that not so much that you're going to distribute the 3, but that what this is actually saying is that you have 3 groups of x minus 2. Okay, so if you have 3 groups of x minus 2, it's going to look something like this. X minus 2 plus x minus 2 plus x minus 2. Okay, so if we see that, and I say, okay, well, how many x's do we have up there? X plus x plus x, 3x. And if I subtract 2, subtract 2, subtract 2, I have negative 6. Okay, so there's a 2-step process here. The first step is you're breaking it down. You're really breaking it down to this, okay? That's what you should see in your head. The second step is you combine it all together. This is why we're allowed to come up here and distribute that 3 to the x and to the minus 2. So here's another example. 4z plus 2. Let's see if it still works. We're going to distribute that 4 to the z and the 2. Come up with 4 times z plus 4 times 2. Notice that the inside the commutative property still stays the same. And now let's go down below and see if that still works if we make 4 different groups. So z plus 2, z plus 2, plus z plus 2, plus z plus 2, and we have 1, 2, 3, 4 z's plus 1, 2, 3, 4 2's, which is 8. Still works. Okay, so for our final example, what we're going to do is we're going to multiply, same thing we did before. The only difference is, you see this little 3 here? Well, what are we doing? Are we doing anything different? Well, if we just break it down into its basic parts, you can see that we don't. If I have 4 groups of 3k minus 2, I have 3k minus 2, that's group 1, plus 3k minus 2 plus 3k minus 2 plus 3k minus 2. So 3k plus 3k plus 3k plus 3k, 12k's, minus 2 minus 2 minus 2 minus 2, minus 8. This is why, again, we're allowed to use the distributive property to multiply the 4 times the 3k. 4 times 3 is 12. And then, again, the minus stays there, and then we do the 4 times the 2, minus 8. Okay, so the next step with using the distributive property is understanding that you can do the same thing in reverse. You can undo. And it's very simple because you guys did such a good job of learning the ladder method that we're going to actually apply this to factoring out algebraic expressions as well. So when we see 20m minus 5, what I immediately want you to think is, okay, we got to do the ladder method. And what can go into 20m and go into 5? What can go into both? For now, you can ignore the m, and you can just think 20 and 5. What can go into both 20 and 5? And I immediately think, well, 20 is a multiple of 5, so 5. 5 can go into 20 4 times. M stays. Minus 5 goes into 5 1 time. Come on down. 5 parentheses 4m minus 1. And that's the steps. Now the last thing you should always do is once you factor out a number, you should always check to see if it works out. And what I'm going to do is I'm going to go ahead and use the distributive property to multiply that 5 times the 4m. So there's 5 4m's, which is 20m, minus 5 times 1, 5. Right back at the beginning. So yes, it checks out. We're good. Here's the second example. And in this one, we have 2 different variables, but we still have something in common. Using the ladder method, we're going to pull out what they have in common. And what they have in common is these letters right here. They both have a multiple that can go into both. And that multiple is 3. 3 goes into 9x 3 times. 3 goes into 3y 1 time. So I'm going to bring it on down, take the greatest common factor, pull it on the outside, 3x minus y. And that's it. Now if we want to check our work, multiply the greatest common factor back into them. 3 times 3x is 9x. Notice that the sign stays the same. Bring that straight down. 3 times the y is 3y, which is what we had to start with. Okay, so here's going to be our final example. And I just wanted to show you that you can use the ladder method again, and you can do multiple ladders, and you're going to still come up with the same answer. So if you're heady, you'll know that 12 goes into both 36 and 12. But let's say that you want to break it down into smaller chunks. We can do that. What can go into both 36 and 12 besides 12? Well, I know they're even because they both end in an even number, so I'm going to pull out a 2. 2 goes into 36 18 times. 2 goes into 12 6 times. Same thing. What can go into both 18 and 6? Can either be 2 or 3. Let's use 2 again because that's easier, and we both know that they both end in an even number. 2 goes into 18 9 times. So 9h. 2 goes into 6 3 times. And we're still not done. Still one more variable or one more common factor that can go into either one, and that is going to be 3. That's what's left. 3 goes into 9 3 times. 3 goes into 3 once. And so we bring it on down. We have 3h plus 1, and then we're going to take the greatest common factor, which are these numbers multiplied together. 2 times 2 is 4, times 3 is 12. So let's see if that all still works out, even though we did multiple steps. 12 times 3, h is 36h, plus 12 times 1 is 12. Right back where we started, so it all works out. So if I ask you to factor out the greatest common factor between 36h and 12, you know that the answer is 12 parentheses 3h plus 1.